Hello students. Hello students. Today we are solving some questions on rotational dynamics, and those are objectives. And before I will solve those questions for you, I must give you some background of the rotational dynamics or a summary of it. तो उसी में आप सारे क्वेश्चन फिर कर सकते हैं इसके. Let me start. रोटेशनल डायनेमिक्स में जो बेस रूल्स है, बेसिक रूल्स ऑफ रोटेशनल डायनेमिक्स या रोटेशनल मोशन. पहला यह है कि अगर एक पार्टिकल सर्कल में घूम रहा है ऐसे विद एंगुलर वेलोसिटी ओमेगा, तब जाकर विद सेंटर ओ, अगर ये रेडियस आर है, तो आप मुझे बताइए व्हाट इज द स्पीड ऑफ द पार्टिकल और व्हाट इज द वेलोसिटी ऑफ द पार्टिकल कनेक्टेड टू द ओमेगा, दैट इज आर ओमेगा. अगर इसी चीज को आप डिफरेंशिएट करोगे वेलोसिटी को, दैट इज डी वी बाई डी टी, दैट बिकम्स आर डी ओमेगा बाई डी टी. तो इससे आपको और एक रूल मिलेगा, वो ये है कि ये जो डी वी बाई डी टी है, दैट इज टेंजेंशियल एक्सेलरेशन इज इक्वल टू आर, ये डी ओमेगा बाई डी टी इज एंगुलर एक्सेलरेशन. तो एक रोटेशनल डायनेमिक्स जब आप कर रहे हो तो ये चीज आपको पता होना चाहिए. दूसरा ये कि सेकंड इज अगर एंगुलर मोमेंटम निकालना हो तो आर क्रॉस पी का फॉर्मूला यूज करना पड़ेगा. अगर टॉर्क निकालना हो तो आर क्रॉस एफ का फॉर्मूला यूज करना पड़ेगा. फोर्थ, अगर एंगुलर मोमेंटम निकालना है उसका फॉर्मूला ये भी लिख सकते हैं, आर पी परपेंडिकुलर, मतलब मोमेंटम जो आर को परपेंडिकुलर हो या पी को आर परपेंडिकुलर के साथ मल्टीप्लाई करो, यानी कि उस द आर एंड पी which are perpendicular to each other, just multiply them and get the angular momentum. And same can be said about this. That is fifth, that is torque is equal to r f perpendicular, और ऐसे लिखा जा सकता है, that is f r perpendicular. मतलब आपको फोर्स और r को मल्टीप्लाई ही करना पड़ेगा अगर वो आपस में परपेंडिकुलर है, आपस में 90 डिग्री का एंगल बनाते हैं. But let me start now question. Let me start a question. Question number 1. If the angular speed of a flywheel moving with a uniform angular acceleration changes from 1200 revolutions per minute to 3120 revolutions per minute in 16 seconds, what is angular acceleration in radians per second square? So first of all, what is the relation? What is the formula for angular acceleration? That is, angular acceleration omega is delta omega by time interval. Delta omega means final angular velocity minus initial angular velocity by time interval. That is the formula for angular acceleration. But here you are given revolutions per minute, but omega is radians per second. You have a relation between omega, angular frequency, and frequency omega is equal to 2 pi f. Here you are not given omega directly. You are not given omega 1 and omega 2. You are given f1 and f2, final angular, final frequency and initial frequency. But जो हमारा फॉर्मूला है एंगुलर एक्सेलरेशन के लिए, वो ओमेगा 2 माइनस ओमेगा 1 बाय डेल्टा टी है. इसलिए ये जो ओमेगा f है, we have to convert that into omega. So if I start from here, so alpha is equal to, what is omega 2? Omega 2 is 2 pi f2 minus 2 pi f1 by delta t. Right? So if we go ahead, 2 pi को कॉमन निकालिए, f2 minus f1 by delta t, ऐसे कुछ. तो इसमें और एक चीज है कि 2 pi को ऐसे लिखिए. What is f2? f2 is 3120, f1 is 1200 by delta t, that is 16 seconds. मगर ये जो है ना, it is revolutions per minute. In SI system, you don't write revolutions per minute, you write revolutions per second. तो revolutions per second के लिए इसको divide करना पड़ेगा 60. Okay. Now alpha is equal to, ये हुआ 2 pi. तो इसको सब्ट्रैक्ट करने से क्या क्या सब्ट्रैक्ट करेंगे आप? 0 और it is 0, it is 2, it is 11 में से it is 0, 2 हो गया 2, it is 11, it is 9, it is 3, 2 में से it is 1 divided by 16 into 60. This cancels off. It is 6, 3, 18, 2. It is 16, 2. It is 4 pi radians per second square is the answer for this question. This is the answer. Question number 1 is done. So the concept was like this: you are given initial angular velocity, and you are given final angular velocity, and and you are asked to find what is angular acceleration. So angular acceleration is final angular velocity minus initial angular velocity divided by time interval. But here it was given f, revolutions per minute. So first of all, you convert revolutions per minute, that is f, into omega, because omega alpha is given in terms of omega. Question number 2. Two objects of mass 10 kg and 20 kg respectively are connected to two ends of a rigid rod of length 10 meters with negligible mass. The distance of the center of mass of the system from 10 kg mass is. Question कुछ ऐसे है, आपके पास दो masses है, 10 kg and 20 kg, और आपको center of mass इनका निकालना है, और वो center of mass 10 kg से कितना दूर है. So let me make the model of the question. It is 10 kg here, it is 20 kg here, and distance between them is 10 meters, right? And it is in kgs. And center of mass obviously will lie on the line joining their centers on this line. तो center of mass इसी line पर lie करेगा, लेकिन और ये भी कि center of mass will be closer to the huge mass, greater mass side. Center of mass always lies towards the greater mass side. तो center of mass कहीं यहाँ पर हो सकता है, और center of mass अगर यहाँ है तो it can balance here under gravitational forces. अगर आप center of mass कहीं है तो ये दो masses जो है ये किसी wedge पर या किसी triangular shaped wedge पर ये balance हो सकता है, क्योंकि center of mass is also the center of gravity when you are closer to the surface of the earth. तो यहाँ पर ये balance होगा. अगर balance होगा तो इसका मतलब moment from this side should be the same as moment from this side. Suppose ये distance x है और बाकी जो बचा distance that is 10 minus x. और अगर ये 10 minus x है और ये x है, तो उस सूरत में आप एक इक्वेशन लिख सकते हैं, moment from the left side should be equal to the moment on the right side. So what is the equation that we are going to write? 10 mass into this distance, center of mass to the mass point, that is x, should be equal to 20 into 10 minus x. We have to find x because the question says that how much distant center of mass is from the 10 kg mass. So what we do is 10x is equal to 200 here minus 20. Okay, x. We could have cancelled this. We could have cancelled this 0 here. Okay. It is 0 cancels. It is x is equal to 20 minus 2x. That will make 3x is equal to 20. That will make x is equal to 20 by 3 meters. That is the answer. 20 by 3 is the answer for this. Okay, let me go to the next question. 4th. A uniform rod of length 200 centimeters and mass 500 grams is balanced on a wedge placed at 40 centimeters mark. A mass of 2 kg is suspended from the end at 20 centimeters, that is here, and another unknown mass m is suspended from the rod at 160 centimeters, that is here, as shown in the figure. Find the value of m such that the rod is in equilibrium. It is a rod having some mass of 500 grams, a rod, and There are masses hanging and it balances at some point. We have to find how much mass should be on this side so that it gets balanced. That is the question. The question is, how much should be this mass? It can be found by finding the moments about this line. So what is this distance? It is 40 minus 20, that is 20 centimeters. And how much is this distance from here to here, where this M is hanging? That is 160 minus 40, that is 120 centimeters. Also, this rod has a mass. The rod, जो rod है, उसका जो mass है या उसका जो weight है, that always acts at the center of mass, downwards. So here is a point where the mg acts downwards, means the weight of the rod. That is, now how much is that? Weight may be mg, but we are concerned only with m. What is m? That is 500 grams into 10 raised to the power minus 3. That will make it 0.5 kg. Now, as we know, okay, let me find this distance also, because this is also important. This point from this end is 100 centimeters. Why? Because the total length of the rod is 200, and midpoint should be 100 from this point O, 0 point. And what is this distance? This distance should be 100 minus this 40. From here to here is 40. From here to here 100. 100 minus 40 is, okay, 60. So we have to find this mass. What should be the mass here so that it is all balanced? Okay? Okay, let me write down the equation now. Writing down the equation is, it is balanced about this. So left-hand side moment should be equal to right-hand side moments. What is the left-hand side moment? Left-hand side moment is 2 kg into 20 centimeters. Right? We don't need to convert centimeters into meters because everything is in centimeters. That will cancel from the two sides. So is equal to, what are the moments from this side? That is 100 into 60. 60 centimeters into 100. No. It is 2 into 20. It is, what is the weight here? 0.5 is the mass into 60. That's the moment produced by this mass. And plus m, how much is the distance from here to here? 120. Right? We have to find this m. So it is 40 is equal to 30 plus 120 m. Right? If you get this 30 on this side, that is 10 is equal to 120 m. So how to find m from here now? So m is equal to, that is 10 by 120, that is 1 by 12 kg. That's the answer. Finished. So the concept was just a rod there. It was balanced at a wedge by masses, by 3 masses, mass, unknown mass, its own weight, and also the weight from this side, 2 kg. It was balanced under these three masses. We have to find how much is the mass so that it gets balanced at this point. Very simple. Moments from this side equate to the moments from this side. It is basically torque. Torque from this side should be equal to torque from this side. But G cancels all throughout. अब gravitation का जो G है वो cancel हो जाएगा. इसलिए we get moment from this side is equal to moment from this side. Next question. Question number 4. 3 identical spheres, each of mass are placed at the corners of the right angle triangle with mutually perpendicular sides equal to 2 meters. Taking the point of intersection of the two mutually perpendicular sides as the origin here, find the position of the center of mass. We have 3 masses. This one, and this one. And we have to find the position of the center of mass. That's so simple. You just directly write the equation of the center of position of center of mass equation, or equal to m1 r1 vector plus m2 r2 vector plus m3 r3 vector divided by summation of masses. Now, what is r for this vector? Or for this vector, write down, let me write down the coordinates of this. That is 2, 0, because 2 is the x coordinate, 0 is the y coordinate. And here, what is this coordinate? That is 0 and 2. What is this coordinate? And 0 and 0. Directly write the coordinates. Or equal to, what is m? That is capital M here. Uska coordinate 0 है, तो write 0 plus m2, that is also m. Uska coordinate क्या है? What is its coordinate? 2i plus m again. What is its coordinate? 2j divided by 3m. Sum of the masses m, m, and n. So what is it? Is radius vector or position vector of the center of mass. That is 0. That is m, and m gets cancelled. 2 will be common. ऊपर से 2 कॉमन होगा, नीचे 3 और I plus j. That is the answer. That should be the answer. Answer D. That is R equal to 2 by 3 I plus j. Finished. Okay, this is the answer. Now let me go to another question. Find the torque about the origin when force 3j and x on a particle whose position vector is 2k. It's a unit vector 2k. Directly write the equation. We have to find the. Okay, if you allow me to make this what you call as a figure of it, I will take a coordinate system. It is r vector. And this is force F. R is given to be this, and force is given to be this, and we have to find the torque. That is, by definition, torque is equal to R cross F, right? So why not to write directly? Find directly the answer. Torque is equal to, what is R? That is 2k unit vector cross 3j Newton. That is torque equal to, that is 6 k cross j. That is 6. What is k cross j? That should be minus I. So I, j, k. This j cross k like this. That is minus I. That is minus 6 I Newton meter. Answer. Very simple. That is the answer. This is the answer. So it is very simple. You have to use the formula. You are given force, you are given the radius vector, position vector, and you just have a cross product of these two and you get the answer. Okay, let me go to one more question. Two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from 5 kg. 5 kg से कितना दूर है? The same as before. This is a 5 kg mass. This is 10 kg mass, and center of mass should be lying closer to the 10 kg. Yes, because it is heavier one. We have to find center of mass position from 5 kg. This x we have to find. Obviously, the distance between this and this is 1 meter, so it is 1 minus x. Remaining distance 1 minus x. The concept is that the system should balance at the center of mass, so that the moments from left side should be equal to moment of the right side. So which equation I should write? What's the moment on this side? What's the moment on this side? That is 5 into x is equal to 10 into 1 minus x. So 5 2, it is x is equal to 2 minus 2x. That will make 3x is equal to 2. That will make x is equal to 2 by 3. 2 by 3 meters, or in centimeters 2 by 3. X is equal to 2 by 3 into 100 centimeters. That will make it 67 centimeters. Answer is this. Finished. Very easy question. Okay. Next, 7. The moment of force means torque. You must know that. Moment of force means torque. The moment of force F at this, about the point this. About this is the point where the force acts, and this is a point which is away from the origin. So first of all, basically, if I make a model of the questions like this, you apply force here, but you apply force at which point? 2, 0, and -3, you apply force at this point. And about the point, you are applying force at this point, but about which point you have to find the torque? About some other point. That other point is 2, -2, and -2. This is another point. So first of all, you have to construct what is the radius vector. That's R, this one. You are applying force at a point this, but you have to find torque about a different point, that is this point. First of all, you have to construct this R. How do you construct R? You have a formula. R vector is equal to, if you have 2 points, that is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. This is the formula for constructing the radius vector. If this point is generally origin, that's why you just write the simple formula. But if the point is not the origin, it is some other point, then you have to, first of all, you have to find the radius vector. The radius vector will be found by this formula. So what is R? That is, okay, x2, that's 2 minus 2, that is 0 minus of -2, that is plus 2j, -3 minus 2, -3 of -2, that is minus k. This is R is equal to 2j minus k. This is the radius vector. Again, I will explain. First of all, you have to come with the radius vector. Generally, what is given, this point is always the origin, and you are given directly R. But if you are not given directly R, you are given 2 points, then you have to, first of all, you have to construct R. How do you construct R? Radius vector. Construction of the radius vector, that is constructed by this formula. If you have 2 points, you find the difference of x coordinate of 2 points, y coordinate of 2 points, difference of z coordinates of 2 points, and finally you find this R. And F you already know. That is 4i plus 5j minus 6k. This is F. So how to find now torque? Now see how to find the torque. Torque is given by R cross F. Or you can make it like this: I, J, and K. And now write the x components of x component, x, y, and z components. This are, that is 0, that is 2, that is -1. Right? And then you write the force components: 4, 5, -6. Now, how to solve this? It is I times, multiply these crosswise, that is -12 plus 5. -12 minus of -5, that is plus 5. Minus j, multiply 6 and 0, that is 0. Multiply 1 and 4, that is -4. It will be 0 plus 4. Plus k times, multiply this 0, it is -8 here. It will be -7i minus 4j minus 8k. That should be the answer. That should be the answer. That should be the answer to the question. This is the answer to the question. Okay, let me go to the next question. That is, a rope is wound on a cylinder. It is hollow cylinder or a solid cylinder, we have to see. A rope is wound on a cylinder of mass 3 kg and radius 40 centimeters. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton? There is a cylinder on which we wrap a rope, and we pull the rope so that the cylinder rotates. We have to find the angular acceleration of the cylinder. It's something like this. It is a cylinder, maybe solid, maybe hollow. It is not clear here. It is pulled by, it is wrapped by a rope, and the rope is pulled with what force? 30 Newton force. 30 Newton force. And it is radius is, okay, R, that's given to be 40 centimeters. And the mass of this cylinder is 3 kg. Right? And when it's pulled, it will rotate. We have to find its angular acceleration. It is something like this. There's a cylinder like this. It is wrapped by a rope, and rope is pulled. And when the rope is pulled, it will rotate. And we have to find the angular acceleration. Okay, let me find the torque by this tension or this force. So torque is equal to R and 30 into R, simply. 30 into R. Yeah, okay. Let me write down force into R, and I will substitute at the end. Then I will substitute at the end. This torque is equal to R and F. This R and this F, because they are perpendicular and they simply multiply. This is torque, and you know torque is also equal to I alpha. It's RF. It is the same thing. F is equal to ma. Torque is equal to I is the same thing as F is equal to ma. Now, what is alpha? Angular acceleration. That is RF by I. Now I will substitute here. Now this is alpha is equal to what is R? That is 40 centimeter. 40 into 10 raised to power minus 2 meters. What is F? That is 13 Newton. Divided by what is I? Moment of inertia of this cylinder. If it is solid, that is 1 by 2. Mass of the cylinder is what? 3 kg. And what is R? First of all, let me write the formula. Let me write the formula. That is 1 by 2 m r square. और एक r ऊपर कैंसिल भी हो जाता. Why should we substitute r two times? It is alpha is equal to, it is r into f by 1 by 2 m, okay, r square. 1 r gets cancelled. So alpha is equal to 2f by mr. Now we will substitute. Alpha is equal to 2 times, it is 30 Newton. It is m is what? What is mass of the cylinder? That is 3. That is 3 into what is R? That is 40 centimeters. 40 into 10 raised to power minus 2. 3 gets cancelled, 0 gets cancelled, 3 gets cancelled. It is 1 by 2. 1 by 2 over 100. So it is 50 radian per second square. There is no such answer. कहाँ गलत हुआ? Let me check it out. Let me do it. Let me check it out again. But अगर मैं, is it hollow cylinder or a solid cylinder, that we have to see. But I have taken solid cylinder. Should I take hollow cylinder? Because it is not clear here. Okay. Chalo ji. It is alpha is equal to, it is RF by I. That is alpha is equal to what is R? R is R, F is F, and what is I? That is M R square. If it is a hollow cylinder, it is cancelled out. This alpha is equal to F by MR. F is equal to 30 Newton. M is equal to, what is the mass of the? It is 3. It is 3 into what is the radius of the cylinder? Possibly radius 40 centimeters. Yes, 40 centimeters into 10 raised to power minus 2. Okay. Now this gets cancelled. This gets cancelled. It is 100 10 पर माइनस 2 ऊपर जाकर के 100 होगा और नीचे 4 it is 25 रेडियंस पर सेकंड स्क्वायर. हाँ, यहाँ पर जो मैंने चेंज किया वो ये है कि यहाँ ये हॉलो सिलेंडर होना चाहिए, जो पहले मैं समझ नहीं पाया. ओके. So the question was something like this. It was a cylinder like this. It was wrapped through by a string, and you were pulling the string with a force of 30 Newton, and it would rotate. And we had to find what is the angular acceleration. So it's very simple. Torque is given by torque is I alpha, and torque you get from the equation from the diagram, and equate to get the answer. Okay. Now let me go to the next question. A rod weight of a W is supported by two parallel knife edges A and B, and is in equilibrium in a hollow position. The knives are at a distance of mass of rod is at a distance x from A. The normal reaction on A is a rod of W. I think the question is something like this. There's a rod, and these are two knife edges A and B. It is balanced, and distance between the two is D. Right? And the rod of a W is supported by two parallel knife edges A and B, and is in equilibrium in a position. The knives are at a distance x from A. So the question should be something like this. Two knife edges at a distance A and at a distance x. The question is not clear. I think there's something is missing on the question. A rod of AW is supported by two knife edges A and B in equilibrium. At the knife edges. The knives are at a distance D. The rod is D and x from A. Let me go to the next question. The question is not clear. We have to check the question again. Okay. Or I will come back to the question. An automobile moves on a road with a speed of 54 kilometers per hour. The radius of its wheel is 0.5 meters, and the moment of inertia of a wheel about the axis of rotation is this. If the vehicle is brought to rest in 15 seconds, the magnitude of average torque transmitted by these brakes to the wheel is. The question is something like this. The wheel is rotating and moving in the forward direction with angular velocity with the speed given, and the driver applies the brakes and it comes to the rest. We have to find how much torque is applied by the braking force. That's it. It's a wheel, something like this. It's a wheel here. It moves in the forward direction with some velocity that is 54 kilometers per hour. Okay, let me make this 54 kilometers per hour in meters per second. That is pi by 18. That is it will be 15 meters per second. Right? And the radius of the wheel is also given, and that is given to be what? 0.45 meters. Right? Now the driver applies the brakes. So he applies the brakes and the force is applied in the backward direction. We had to find, and it is brought to the rest in 15 seconds. We had to find how much is the average torque transmitted by applying the brakes to the wheels. So how the question can be done? Let us go direct is try to solve the question. Direct is if you want to find the torque. So what you do? You just write the torque equation. So torque is equal to that is F into R. This is the torque equation. This is the torque equation, and also is equal to I alpha. Is also equal to I alpha. So torque is equal to, it is I What is alpha? Angular acceleration. That's final angular velocity minus initial angular velocity by time. फिलहाल ठीक है? Okay. Now torque is equal to I, moment of inertia of this of that wheel that we have to find. Possibly that will be given into what is final angular velocity when the wheel stops. What should be its final angular velocity? That is 0, right? What is initial angular velocity? He does not give initial angular velocity. Instead, he gives velocity and radius. So you already know, which I have given in the beginning, omega is equal to V by R. So it is V by R here divided by delta T. Now, what is I? Moment of inertia should be given somewhere. That is moment of inertia of the road with the speed of this wheel about vehicle is brought to rest in minutes, seconds, next a minute. And automatically this the moment of inertia of the wheel about the axis is 3 into what is velocity? That is 15. What is R? That is 0.45 divided by how much is the time taken to get it into rest? 15, something like this. So 15 gets cancelled, right? And we have to write here 3 times 3 by 0.45. So that is 3 multiplied by 100 upar by 45. ठीक? That is 3. It is 20 by 3. Should be the answer. Let me see. $20 by 3 should be the answer. So where is the answer? 20 by 3. 20 by 3 is 6.66. That is the answer. Kg meter square second inverse 2. This is the answer. So the concept was like this. You see, there was a cylinder. There was a wheel. You apply the brakes, it stops. But first it was given velocity. From this velocity, you find the initial angular velocity. And when you apply the brakes, it will stop. When it stops, final angular velocity is 0. So what is torque? Torque is equal to I alpha. I, the moment of inertia you are given. Alpha is final angular velocity minus initial angular velocity by time. Final angular velocity, you know, should be 0 because it has stopped. Initial angular velocity, he has not given you directly. He has not given you initial velocity directly, initial angular velocity directly. Instead, he has given you initial velocity and angular radius. So he means that you should be able to find angular velocity initially from velocity and the radius of the wheel. Okay, that's done. Okay, next question. A force, this is acting at a point F, at a position this. The value of alpha for which the angular momentum about the origin is conserved. The question is when the angular momentum gets conserved. You must know by law, by basic simple law, when torque is 0, then angular momentum is conserved. So what should we do? We'll make the torque 0 because angular momentum is conserved and find alpha. So let me start from here. Torque is R cross F. What is torque? That is 0. Because he does not say torque is 0. Instead, he says angular moment is constant. But that implies what? उसे क्या मुराद है? उसे मुराद ये है कि torque is 0. Right? So basic rule ये है कि if there is no external torque, the angular momentum of the system remains constant. So what is R? तो ये है, चलो मैं इसको ऐसे ही करता हूँ, I, J और K वही determined form से. तो R के components 2 minus 6 minus 12. अब F के components alpha 3 6. अब ये निकालना पड़ेगा. It is I times, इनको multiply करना पड़ेगा, minus 36 plus 36. ठीक. माइनस जे, ये 12 प्लस 12 अल्फा, ये मल्टीप्लाई करके ये प्लस के टाइम्स दिस 6 प्लस 6 अल्फा, 6 ये प्लस 6 अल्फा इज इक्वल टू 0, राइट। ये हो गया, समझो। अच्छा, अब आपको पता है अगर एक वेक्टर 0 है, दिस वेक्टर इज 0, ये तो 0 है ही। अगर ये वेक्टर 0 है, दैट इज द कॉन्सेप्ट, इफ ए वेक्टर इज 0 देन ऑल इट्स इंडिविजुअल कंपोनेंट्स आर 0। इसका मतलब अगर ये वेक्टर सारा 0 हो गया, इसका मतलब ये कंपोनेंट भी 0 है, ये कंपोनेंट 0 है, दो में से एक कंपोनेंट 0 बना दो, इट इज 12 प्लस 12 अल्फा इज इक्वल टू 0, या यही सही, ये 0 बना दो तो उसे अल्फा इज इक्वल टू -1 आएगा। तो लेट मी फाइंड द आंसर, ये है आंसर। Let me go to the next question. A solid cylinder, clearly a solid cylinder of mass 50 kg and radius 0.5 meters is free to rotate about a horizontal axis. The master string is wound around the cylinder with one end attached to it and the other end hanging freely. The tension in the string required to produce an angular acceleration of 2 radians per second square. तो पहला सिलेंडर, हाँ सिलेंडर है, उसका रेडियस दिया हुआ है और आपने इसको टेंशन दिया है, फोर्स दिया है, तो आपको कहना, आपको ये फाइंड करना है इसका एंगुलर एक्सेलरेशन क्या होगा। सो हाउ टू सॉल्व दिस प्रॉब्लम इन अ डायरेक्ट पॉसिबल वे। लेट मी टेक दिस सिलेंडर, इट इज द फोर्स, टेंशन इज द टेंशन, राइट। टेंशन निकालना है, एंगुलर एक्सेलरेशन दिया हुआ है, तो ये रेडियस है, ठीक। तो सिलेंडर टेंशन इज टू बी फाउंड, एंगुलर एक्सेलरेशन इज गिवन, जिस टेंशन से इतना एंगुलर एक्सेलरेशन आपको बनता है, तो टेंशन निकालना है। तो व्हाट यू डू, हाउ टू यूज द डायरेक्ट इक्वेशन फॉर दिस। ओके, टॉर्क इज इक्वल टू, हैव अ लुक, आर एफ सिंपली, और ये टॉर्क जो है यू नो इट इज आई अल्फा, इट इज आर एफ, यहाँ आर एफ टॉर्क होगा कि 90 बनाता है, यू जस्ट मल्टीप्लाई टी एंड आर। तो आई, मुझे ये एफ निकालना, बिकॉज एफ इज टेंशन हियर, जस्ट आर और टेंशन। तो टेंशन निकालने के लिए मुझे क्या करना होगा, तो आई अल्फा डिवाइड करना पड़ेगा ये आर। तो टेंशन इज इक्वल टू आई फॉर ए सॉलिड सिलेंडर, यू ऑलरेडी नो दैट इज 1/2 mr स्क्वायर इनटू दिस अल्फा by r. 1 r gets cancelled. So what is the tension? 1/2 m r or alpha. It is 1/2. What is the m? What is the m? 50 kg. Sorry. 50 kg. What is r? R is given to be 0.5. 0.5. And what is alpha? Possibly 2. 2. Sorry. 2. 2 gets cancelled. This gets cancelled, point with 0. It is 25 newtons should be the answer. Okay. Let me see. This is the answer. Very simple concept. You have the tension, you have the angular acceleration, and you have the torque equations with you, and you can solve these questions very, very easily. Okay, let me go to the next question. A rod PQ of mass m and length L is hinged at end point P. Hinged is here. Okay. The rod is kept at a horizontal position by a massless string tied to a point Q. As shown, when the string is cut, the initial angular acceleration of the rod is, okay. ठीक, मास m है, रॉड का मास m है, तो हमें निकालना है एंगुलर एक्सेलरेशन। मुझे ये समझ नहीं आता है कि why should we cut this string कट नहीं भी करो तो इनिशियल एक्सेलरेशन वही होगा जो कट करने के बाद होगा. एनीवे आई विल फाइंड द एंगुलर एक्सेलरेशन. तो इनिशियल एंगुलर एक्सेलरेशन कैसे हम निकालेंगे, देखो हैव अ लुक. तो पहले इसका mg वेट डाउनवर्ड्स है, राइट. तो अब इस वेट से कितना टॉर्क प्रोड्यूस होगा अबाउट दिस फिक्स्ड पॉइंट, दैट इज लेट मी फाइंड टॉर्क दैट इज इक्वल टू mg into L/2. this this is the torque. So simple. अब ये टॉर्क है तो मुझे बताइए इस टॉर्क की वजह से एंगुलर एक्सेलरेशन कितना होगा. इट विल रोटेट लाइक दिस, यूं, ये ऐसे रोटेट हो जाएगा, यूं रोटेट होगा इस एंगुलर एक्सेलरेशन की वजह से. अब ये टॉर्क आपको पता है, अगर टॉर्क पता है आपको तो मुझे बताइए एंगुलर एक्सेलरेशन आई अल्फा, टॉर्क का जो इक्वेशन है आई अल्फा mg L/2. Now what is I? Moment of inertia of this rod about this point, not about any other point. अगर आपको याद होगा that is 1/3 m L square alpha is equal to mg L/2. तो L gets cancelled, m gets cancelled, तो alpha is equal to 3 times g by 2 times ये L नीचे आएगा ऐसे. आंसर, this is the answer. But you see, we can make so many questions out of this question. I can ask you what is the acceleration of the center of mass. I can ask you what is this tension produced. If I ask you what is the acceleration of this point, can you give me the answer? The acceleration of this is equal to alpha r. अगर आपको वो पहला ही जो मैंने आपको बताया, alpha is 3g by 2l, and what is r? R is from here to here distance, that is L/2. L gets cancelled, that is 3g by 4 is the acceleration of the center of mass. और एक क्वेश्चन बन गया इसका. If I ask you what is this tension, so how can you give me the answer? Although we have already solved the question, but I want to make more questions out of this. तो center of mass का acceleration भी आपको मिला, और center of mass का acceleration जो मिला आपको, can you find this T tension? तो वो टेंशन आपको कैसे मिलेगा मैं आपको बताऊंगा. 3 क्वेश्चन बन गए इसकी, वो टेंशन भी बताऊंगा. हैव अ लुक. वो टेंशन आप ऐसे निकाल सकते हैं. अब आपको पता है कि इसका एक्सेलरेशन नीचे की ओर क्या है, दैट इज ए, वो आपको पता है. तो कैन यू राइट न्यूटन सेकंड लॉ फॉर दिस? न्यूटन सेकंड लॉ इज ma is equal to net force. M is m, what is a? That is 3g by 4. What is net force? Net force is mg minus t. Mg is downwards, t is upwards. mg minus t. तो t को यहां लाओ, इसको वहां की ओर ले जाओ. t is equal to mg by 4. अगर आप इसको सॉल्व करोगे तो ये टेंशन भी निकाल कर दिया मैंने, एक्सेलरेशन भी निकाल कर दिया. इसके 3 क्वेश्चन बन गए. तो व्हाट योर कॉन्सेप्ट मस्ट बी क्लियर. अल्फा कैसे निकालते हैं, वो टॉर्क बेसिक इक्वेशन से निकालते हैं. हैव अ लुक. चलो जी, क्वेश्चन नंबर 14. Question number 14. When a mass is rotating in a plane about a fixed point, its angular momentum is directed along. हमें एक पार्टिकल है या एक बॉडी है, वो एक प्लेन में मूव कर रहा है ऐसे कुछ वेलोसिटी v से, और ये अबाउट वो मूव कर रहा है इन अ सर्कुलर प्लेन. इट मूव्स रोटेटिंग इन अ प्लेन. तो व्हाट शुड बी इट्स डायरेक्शन ऑफ एंगुलर मोमेंट? एंगुलर मोमेंटम is found from about O. It is r direction, r cross v या r cross p. r cross p that is perpendicular to the plane. वो एक जो पार्टिकल एक प्लेन में घूम रहा है, v क्रॉस r करने से वो जो डायरेक्शन मिलता है एंगुलर मोमेंट का, वो प्लेन को परपेंडिकुलर मिलता है. सपोज ए पार्टिकल इज मूविंग लाइक दिस, द एंगुलर मोमेंट इज परपेंडिकुलर टू दिस प्लेन. So anytime the angular momentum will be like this, perpendicular to the plane. Like if you wind your fingers in the direction of velocity, the thumb will give you the direction of the angular moment. So the answer should be very simple: a line perpendicular to the plane of rotation. First is the answer. First is the answer. Question number 15. Two persons of mass 55 kg and 65 kg respectively are at opposite ends of the boat. The length of the boat is 3 meters and weighs 100 kgs. The 55 kg man walks up to the 65 kg man and sits with him. If the boat is sitting in water, the center of mass of the system will be. It's something like this. There is a boat, and on the boat there are two persons. One is weighing 55 kg and other is weighing 65 kg. और बोट का जो लेंथ है वो 3 मीटर का लेंथ है और बोट का अपना भी मास है 100 kg. अब क्या हो रहा है, ये जो 55 kg मास का जो पर्सन है वो दौड़ के चलता है 65 kg मास पर्सन के पास. तो हमें यह बताना है कि सेंटर ऑफ मास कितना शिफ्ट हुआ सिस्टम का. दैट्स आवर क्वेश्चन. मैं इसको आई विल मॉडल द क्वेश्चन लाइक दिस. दिस इज अ बोट और इसका अपना मास भी है 100 kg और यहाँ पर अ पर्सन इज हैविंग 55 kg मास और ये वाटर में ही होगा ना, बोट वाटर में ही होता है. चलो जी. और यहाँ और एक पर्सन है दैट इज हैविंग 65 kg वेट. अब हमें क्या करना है, ये जो 55 kg का जो पर्सन है ये दौड़े चला जाता है इसके पास. हमें देखना है कि इस सारे बोट इन दो पर्सन्स का सेंटर ऑफ मास कितना शिफ्ट होगा. आपको पता होना चाहिए जब आप बोट पर दौड़ोगे तो बोट पीछे की ओर हटेगा. वजह यह है कि देयर इज नो एक्सटर्नल फोर्स. जो भी फोर्स आप लगाते हैं वो इंटरनल फोर्सेस है. और कॉन्सेप्ट क्या है, इफ देयर इज नो एक्सटर्नल टॉर्क और एक्सटर्नल फोर्स ऑन ए सिस्टम, if there is no external force or external torque on the system, the center of the mass of the system remains at rest. The same, it remains where it is. You cannot shift the center of mass of a system by internal forces. You can shift the center of mass of the system only by external force. जैसे अगर आप बोट में हो और बोट को अंदर से ही पुश करोगे, बोट चलेगा नहीं. आपको पानी को पुश करना है और पानी आपको पुश करेगा. जो पानी आपको पुश करता है वो एक्सटर्नल फोर्स है. सो ये कॉन्सेप्ट निकालने से कोई फायदा नहीं है. ये जब दौड़ेगा यहां तक तो समझो बोट जो है वो पीछे की ओर जाएगा यूं. तो बोट ने अपना सेंटर ऑफ मास पीछे लिया लेकिन पर्सन ने अपना सेंटर ऑफ मास आगे लिया. तो द टोटल सेंटर ऑफ मास ऑफ द सिस्टम विल रिमेन एट रेस्ट. अगर उससे क्वेश्चन होता है कि हाउ मच इज द शिफ्ट ऑफ सेंटर ऑफ मास ऑफ द पर्सन, वो निकाला जा सकता है. अगर ये कह सकता है कि व्हाट इज द शिफ्ट ऑफ सेंटर ऑफ मास ऑफ द बोट, वो भी निकाला जा सकता है. लेकिन अगर क्वेश्चन है कि व्हाट इज द नेट, व्हाट इज द टोटल सेंटर ऑफ मास ऑफ द सिस्टम, two persons at the boat, the answer is big zero. Concept ये है, there is no external force. These were the 15 questions from rotational dynamics, and I hope that you understood all the questions, but one question was there, but it was a little confusing, and next time when I come I will set the question and I will explain it. Thank you. क्या गड़बड़ मगर क्यों कुछ है? देखो